Hello everyone, welcome to Demystifying Networking, where we demystify complex networking concepts. In this video, we are going to have a look at a scenario-based question related to IP TTL. If you have not watched my video on IP TTL, then I would recommend you to watch that video first to understand answer to this scenario-based question. So let's get started and understand what the scenario is in this question. So in this question, we are pinging from PC1 to PC2 with an initial TTL value of 64. And the question asks us what is the TTL value of the echo request packet captured on Gigabit Ethernet 0/0 interface of router R3. So let's get started and try to find answer to this question. If you have watched my video on IPTTL, I am sure you must be able to answer this question in few seconds. So let's pause for a few seconds and try to find answer to this question. I'm sure by now you must have an answer to this question. So let's verify if your answer is correct. When PC1 pings to PC2 with an initial TTL value of 64, PC1 sends an IP packet with destination IP address 10.10.22.22 and a TTL value of 64 to router R1. When router R1 receives this packet, it verifies if that IP packet is destined to the router itself. Router R1 determines that this packet is not destined to the router because the destination IP is not one of the IP addresses configured on router 1's interfaces. The next thing router 1 checks is whether the TTL value in the received IP packet is greater than 1 or not. In this case, the TTL value received in the IP packet, which is 64, is greater than 1. So router R1 performs a routing table lookup for the destination IP address to find the next hop address and the exit interface. R1 then decrements the IP TTL by 1 and sends an IP packet with the updated TTL value of 63 to router R2. When router R2 receives the packet, it also verifies if the packet is destined to the router itself. In this case, the packet is not destined to the router. The router then verifies if the TTL value of the received IP packet is greater than 1 or not. In this case, it is greater than 1. The router then performs a routing table lookup for the destination IP address and finds the next hop address and the exit interface. The router then decrements the IP TTL by 1 and sends an IP packet with an updated TTL value of 62 to router R3. When the packet is received by R3, it also verifies if the IP packet is destined to the router itself, which is not in this case. Router R3 verifies the IP TTL value of the received packet if it is greater than 1 or not. In this case, the TTL value of the received IP packet is greater than 1. So router R3 performs a routing table lookup to find the next hop and the exit interface. Router R3 then decrements the TTL value by 1 and sends the IP packet to PC2. When the packet reaches PC2, PC2 verifies that the packet is destined to itself, and it then processes the packet locally. Now the question was, what is the TTL value of ICMP echo request packet captured on Gigabit Ethernet 0/0 interface of R3? And as you can see on your screen, the answer is 62. Now let's verify the results in the lab. In this lab, I'm going to show you the TTL value of an ICMP echo request packet captured on Gigabit Ethernet 0/0 interface of router R3 is 62. Let's go to PC1 and ping PC2 with an initial TTL value of 64. As you can see, the ping to PC2 is working fine. Now let's go to the Wireshark capture and enter the filter ICMP with the destination IP address of PC2. If you click on ICMP echo request packet and see the TTL value, you can confirm that the TTL value is 62. I hope this video helped you in understanding the concept of IP TTL. Please like and share this video and subscribe to Demystifying Networking for more such useful videos.